this video we're going to continue with global mins and maxes, but this time we're going to try to find them when we're given the formula. Alright, so we're not going to be drawing any pictures here, just going to be calculations, just trying to use calculus, take derivatives and things like that to try and find where this function is going to have its highest point and its lowest point. It might have them in more than one spot. We'll see that. We might see that. But the point is, where are those values located? And if you've seen the video on the graphs, you know that global mins and maxes will only make sense, or at least you're guaranteed to make sense, as long as you're talking about a closed interval. So right here you see we've restricted ourselves only to x values between -5 and 4 and including -5 and 4. And so because we're in this closed interval, we're going to be guaranteed a global min and max. It's just a matter of where they are. Well, we've narrowed it down to 2 spots already, or at least you can narrow it down to 2 spots, where the endpoints or inside the interval, and in which case we'd be looking for the relative mins and maxes, where we have peaks and troughs. Okay, so let's get started. There are a couple steps here. So again, the idea is motivated from the fact that there are only 2 places you could find them, on the endpoints or inside, and if they're inside, they have to be one of the critical values. So that means we're going to have to take derivatives. Let's go ahead and do that. Take the derivative of f. We're going to get 3x squared minus 6x minus 9. Let's just go ahead and factor that right now, because we know to find critical points we're going to have to set this equal to 0. So pull out the 3, leave behind an x squared, a minus 2x, and a minus 3. But of course, you could factor this even more. You see, that's just going to be, well, let's find 2 numbers that multiply to -3 and add to -2. That's just going to be -3 and +1. So x plus 1, x minus 3. Okay, -3 times 1 is -3, but -3 plus 1 is -2. Perfect. Let's compute. So let's just keep it like that. We don't need to compute any second derivatives unless you want to use the second derivative test. But that's sort of the initial thing we'll do. So the first step is just to find critical values. Step 1, critical values, or critical points. Okay, so what are we going to do here? Set the derivative equal to 0. So we have 3 times x plus 1 times x minus 3. Well, that's equal to 0. Alright, so what are the only possibilities here? If we have 3 times x plus 1 times x minus 3 equal to 0, either 3 can equal 0, which is not, x plus 1 can equal 0, in which case x can be -1, or x is -1 rather, or x minus 3 is equal to 0, in which case x equals 3. Okay, so here are our candidates for critical points. So here are our candidates for global maxes. So we have 2 candidates for a global min max. 2 candidates for global min or max. Okay, that's one thing. Now let's go to the next. All we're going to do now is test all those candidates and compare them. So test all possible candidates. Right? So what are all the possible candidates? Well, it's going to be -1. So f of -1. We're also going to have f of 3. Those are our critical points, but we're also going to have what? The endpoints as well. Those are our other candidates. Remember, global mins and maxes over a closed interval can be located inside at critical points or on the endpoints, in which case we have to check -5 and 4. So we have to test 4 numbers. Alright, so let's go ahead and plug these in. So f of -1, well, -1 cubed is -1. -1 squared is 1, so -3, plus 9, plus 15. Remember, I'm plugging these into the original function right here, the original, right? Because we're looking for global mins and maxes of the original function. Where is the original function? Where does it have its highest point? Where does it have its lowest point? So if we compute this, we have -1 minus 3, that's -4, plus 9, that's 5, plus 15, that's 20. Okay, let's go to 3. 3 cubed is 27. But then you have 3 squared times 3, that's just 3 cubed again, so minus 27. Then you have 9 times 3, that's 27 again, but then you have plus 15. And so that's going to give us minus 27 plus 15, which is -12. Alright, let's go to -5. -5 cubed is -125. -5 squared is 25 times 3, that's -75. -5 times -9 is 45, so we have positive 45. And then we have plus 15. So this gives us -200. This gives us 60. So -200 plus 60 equals -140. And then we plug in 4. 4 cubed is 64. Minus, well, 4 squared is 16. 16 times 3 is 48. Minus 9 times 4, which is 36. Plus 15. So let's see what we can do here. We're going to have 64 minus 48. That's going to be 16. Okay, so let's just write that down. 16 minus 36, well, that's going to give us -20. And -20 plus 15 is going to give us -5. Alright? And so where's the global max? The global max is right here at x equals -1. Let's call that GM. Whereas the global min is going to be located at x equals 5. And that's the global, so let's call it G max. And this one we'll call G min. Alright, it's -140, so that's obviously the lowest value of the function over this interval. Okay, over this interval. And you see, it's very simple. You either look inside the interval, you get candidates from there, you search for the critical points, and the second, you test all the possible candidates, which are the ones inside the interval, the critical points, or the endpoints. Alright? And we have, in this case, a global max at inside and a global min, a global max inside, yes, and a global min on the outside, which is to say on the endpoints. And remember, this depends on the interval itself, -5 to 4. If that interval changes, let's say we put -5 to 6, maybe one of these values would change. Okay, and that's all.